Fermi estimation question, an example. So in Ireland in February, there was a deposit return scheme um, launched whereby you have to pay a deposit when you buy a bottle or a can of soda, and you get your deposit back when you return the bottle or can to the shop. And that was in February, and it's October now, and I want to estimate how many bottles have been and cans have been returned in the scheme. So I'm going to start off with 500 million. That's the population of Ireland to one significant figure. And now we need to think about, so that's the population. I'll just write pop for short. And now we need to think about how many of those people are eligible for drinking sodas, because obviously little babies aren't going to, or other people. So, I'm going to say it's a pretty high percentage, but not 100%. So again, one significant figure. So that's 80%. So that's the percentage who actually can drink. Now, how much would they drink a day? I know some people might be nearly zero on average a day. Some people would drink a can or a bottle every day, or maybe one every 2 or 3 days. So to me, 0.5 seems like a good estimate. This is cans per day. And this is over 8 months. I mean, it started sometime in February and we're at some point in October. So let's say 8 full months. Again, one significant figure. And then 30 days a month. So that's months. That's days. And then we have to multiply by how many people actually do return. So it's not 100%. Some people put their cans and bottles in the bin, never to get their deposit back. It's also not 0% either, because people do return. I'm more ignorant about estimating this than the others. I have no intuition on what to guess, so I'm going to say 0.5. Half the people return. If I multiply these together, I get 24 times 10 to the 1, 2, 3, 4, 5, 6, 7. Or that's 2.4 times 10 to the 8. Fermi said this number should round down if it's less than root 10 and round up if it's more than root 10, which is about like 3.1. So this rounds down to 1. So that's 10 to the 8. So our answer is 1, 2, 3, 4, 5, 6, 7, 8. 100 million. Now, that actually really surprised me. That seemed like way too many for like not even a full year. 100 million. And then after doing the calculation, I Googled it and I couldn't believe it. It's reported as 500 million. So it is the correct order of magnitude. The true answer is 5 times more than this, but it gives us the correct scale, correct order of magnitude. So when I first did this calculation, I thought, no, I must have done something wrong. It couldn't possibly be this big, but it is. It is. Actually, the most recent one says 630 million. This one's saying 500 million. So, yeah, in other words, the scale is hundreds of million. So this is correct.